Welcome back, wonderful students. This is Mr. Ndabezita or Papa Fanzo once again. Wonderful people, we are looking at tangent lines and the derivative at a point, because this can be very confusing for many students. Many of the students struggles a lot to understand and grasp fully this type of content, because now it deals with the limit from left and right and exactly at that point, and it also deals with acceleration and everything that goes along with that. So it's a little bit more confusing for the others, right? So what are we going to do? We're going to try and find a tangent line to the graph of a function. And you might want to go back into my tutorials and want to check what a function is. You might also want to go into my tutorial and look at the limit from left and right and see how that works out before you can come and look at the derivative at a point, because it will necessarily take you back. Now let's just have some reading so that we get a clear understanding as to what we will be trying to do here. To find a tangent line to an arbitrary curve y equals f at x at a point P. So when we say the curve is arbitrarily, that is to say we are dealing with a curve that is not a straight line. We are dealing with a curve whose gradient changes every now and then. Okay, right? So you want to find the tangent at a point P with the coordinates x0 and f at x0. Now we will be using some procedure of the limit, which I have already dealt with. We calculate the slope of the secant line through P and a nearby point, which is qx0 plus h and f at x0 plus h. So what are we saying here? We are having a function y equals f at x, and this is a continuous function. It is continuous everywhere in its domain, of course. And then we want to find the what now? We want to find the tangent of this function at a point P with the coordinates x0 and f at x0. Remember, this would be the corresponding y value. You plug in the value of x on your machine and you get the corresponding y value. This type of notation has been dealt with very much in my tutorials. Now, and then we will be using the procedure of the limit. We will be using limits in order to proceed in this. Now, what are we doing? We calculate the slope of the secant line through P and a nearby point. So the slope of a secant line. Now, we can have a secant line which is a straight line, of course. So for example, let me show you what I'm trying to demonstrate here. Now suppose we have a curve like this, and this is what we call y equals f at x. It is a continuous function in its domain, right? So we are saying, this is very important, we calculate the slope of the secant line through P and a nearby point Q. So okay, so I can say maybe I have a point here and I have a point there, and you might say this is not nearby. I'm trying to demonstrate here, guys. I cannot bring this here. How will I show you the coordinates if they are too close? You just have to know that they need to be as near as possible to one another, but I'm separating them like this so that I can be able to draw up and show you what is happening here. So don't say they are not nearby in that sense that they are distant from one another. I, Papa Fanzo, distant from one another, right? So we will have the first coordinate, the first point with the coordinates x0, f at x0. You know this, we have dealt with this. Let me just close it. and I can have another point here, which I can say this point is Q, and Q will have the coordinate XO plus H and F at XO plus H. So what is this now? This is the distance that separates P and Q. So meaning you have X and you have your H, and the distance from X to H is X plus H. I want you to understand this, because remember we said we will be using the principles of the limits in order to get this. So please be very, very careful. Or let me just show you this. Let me show you this. This is X and this will be H. So the difference in here, the distance from this to this, will be X plus H. Very, very important. Or I can use XO, and let me just say here XO plus H. Let me just do it in that way, and we have the origin there. Alright, if that is fine, and I try to draw a right angled triangle in here with an angle of 90 degrees, then you would know that the change in the y, that would be, of course, this would be F at what? XO plus H minus F at X. This is very important. That would be the change there. Highly and highly important. So XO, F at XO. So that would be the difference here. Now remember what we have. We have this. What is the coordinate here? Remember we are on the y. This is the y. It represents the y axis. And what is your y? That is XO plus H. There it is. Minus, why am I saying XO? Remember, this is y, the distance from here to there. You have a bigger number minus a smaller number. The bigger one is XO plus H minus the smaller one is F at XO. Here it is. This is very important. Now remember, the coordinates of P is XO and F at XO. So that would represent y. And these ones, the coordinates are XO plus H into F at XO plus H, which is the corresponding y value. This is very, very important. And where do I get that? Now, in here, I want you to check what is the value of X here. It is XO plus H. There it is. So meaning the corresponding y value will be F at XO plus H, because you'll be taking this value, substituting to the machine to get the corresponding y value. These are the fundamentals of Papa Fanzo, so that we understand exactly what we are doing here. Hence I'm explaining in this manner. So meaning here, the difference here would be y2, which is this, very important, F at XO plus H, there it is, minus y value. What is another y value there? I want you to check. Remember, this is X and Y. Remember, and I am focusing on Y in here. I am focusing on Y, initial Y and final Y. Remember, so the final Y is this and the initial Y is that. Remember, we are here. We are here. The coordinates in here would be the value of Y, which is XO plus H, and the value of Y1 or initial, that would be F at XO. Is this making any sense, guys? Now remember what we are saying there. Let me do it in this way. We have P, XO, F at XO. We have Q, XO plus H, and F at XO plus H. Right, what I'm saying is, Remember, how did I find the coordinates there? Now, remember, I'm saying, okay, I'm having an x value there. And what would be the final x value? The distance between this and this would be xo plus h, because I don't know what value is there. So I am using h to say, okay, the distance from xo to this distance here will be xo plus h, where h is that distance you add to this in order to get the value here. Right. The corresponding y value, the coordinates of q, so obviously x will be that xo plus h, there it is, and then the corresponding y value would be u, substituting this into the machine to get the corresponding y value. So we are fine in here. So this is what we have. So in here we are saying, okay, the change here, the change in y will be y final minus y initial. So remember, this is x1, y1, x2, y2. So that would be y final, which is f at xo plus h, minus y initial, which will be f at xo. This is exactly what we are having there. I think now it's making a lot of sense. Okay, that is fine. So in other words, we have the coordinates and so on. Everything seems to be fine. So we are therefore saying, we then investigate the limit of the slope as h approaches 0. Now we want to investigate the limit of the slope as h approaches 0. Right. If that limit exists, we call it the slope of the curve at P, okay, and define the tangent line at P to be the line through P having that slope. This is very important. Let us read this. We then investigate the limit of the slope, okay, as h tends to 0. That is fine. Okay, so as h tends to 0, so meaning if h tends to 0 and this is h, meaning h is becoming so small in the manner that either this point is moving towards P so that the gap there becomes infinitesimal to a value of 0, or either this point is moving to that point in such a manner that the value of h becomes 0. This is what we are saying. And if that limit exists, because it is a value, remember the gradient is a value. If the limit exists, we call it the slope, which is the gradient of the curve at point P. Remember, we are saying at P, at point P, and define the tangent line, and we define the tangent line at P. So meaning this is where the tangent is defined. And remember, a tangent is a straight line that only touches the function at one point. All right. And then we define the tangent line at P to be the line through P having this slope. Which slope? Now, the slope of the curve y is equals to f at x at point P is a number, and it is given by the limit as h tends to 0, f at xo plus h, very important, minus f at xo all over h. Very, very important. And this is only provided if the limit exists. We only use this to find or to work out the gradient of a function or the slope of a function if the limit exists. If it does exist. Now, the tangent line to the curve at P is the number through P with this slope. Alright, that is fine. That was quite a mouthful. I might have repeated some other things there, unnecessarily so, but I wanted to ensure that we all follow. Now, let us look at an example that might give us an idea as to exactly what is happening here. So let us look at an example. Right. They say find the slope of the curve y equals, so we have y equals 1 over x. At any point x is equals to a, provided that a is not equals to 0. What is the slope at the point x is equals to minus 1? So we want the gradient at x equals minus 1. Find the slope of the curve y equals 1 over x at any point x equals a, where a is not equals to 0. What is the slope at the point x is equals to minus 1? Now, we know that in order to find the slope at a point of a function, we need to find the limit, and if that limit exists, therefore we can be able to work out the gradient. Now, the first thing we will do is to say the limit as h approaches 0, x plus h minus f at x all over h. We start first by writing the formula, but let's write this formula in a sense that it is making, let us write it in such a manner that it makes sense based on what we are provided with here. So I might want to say the limit as h approaches 0 of f at x plus, so x equals a. So where I see x, I'll be writing a. So I change that. So that will be a plus h minus f at, where I see x, I write a divided by h. Now this is us trying to understand now. Now I'm going to apply this in this. So I'm going to say the limit as h tends to 0 of 1 over, where I see x, remember I'm writing a plus h. A plus h minus my function will be 1 over a, because remember I was told at x is equals to a. Alright, and then from here I divide all this by h. Jesus. And then from here one requires the understanding and the principles of algebra. Right, what I'm going to do there, I'm going to take out an LCD. So the limit as h tends to 0, my LCD is a plus h into a. This into this goes once, this times this is a. This into this goes once, this times this is a plus h divided by h. The limit as h approaches 0, remove the brackets, a minus h, a plus h into a, change division to multiplication. Sketch. Right, the limit as h tends to 0, this and this will go out. Okay, this and this will go out as well. You are left with minus 1 a into a plus h. Are we fine? Wonderful people. Are you alright? Is alles reg? My wonderful people. Then from here, because now I can allow h to be 0 because I have got rid of that. Now I can just go on and substitute the value to be minus 1 into, now remember what they said. In here I can multiply. In here I can multiply and find a squared plus ah. But remember I'm letting this to be 0. So I might as well just get rid of this, because you will have 0 times a, which is 0. So you are left with this. The answer is minus 1 over a squared. But remember what they said. They said, what is the slope at the point x is equals to minus 1? So I'm just going to say minus into minus 1 squared, which will give me what value there? What value will I find there? Let's check. The value would be minus 1. That would be the value. You would get the slope of minus 1 there. Okay, that is fine. And then what is it that we need to learn from this? Right, the first thing that we need to check is that we kept on writing limit, but when you reach your final answer, you no longer write the limit, you just calculate the gradient and find us the answer. This is one most important thing to note here. Highly important. And then secondly, what is it that we need to note here? One most important thing that we should note here is when a is equals to minus 1, the slope is minus 1. And even if a is equals to positive 1, the slope would still be minus 1. Why? Because this is an even number. The exponent is an even number. So even if a was negative, we would still get the slope of minus 1. And even if it is positive, there is no change. Because you are squaring a negative number, you get a positive number. Right, let's look at number B. They say, where does the slope equals minus 1 1/4? They want to know, where does the slope equals minus 1 1/4? And this is something that we need to answer. Now, remember the slope. One thing that we should always keep in mind is that, remember, y equals 1 over x, which was provided to us at a point where x is equals to a. We found that to be minus 1 over a squared. This is very important. And this will be minus 1 1/4, provided that minus 1 over a squared is equals to minus 1/2. This is something very important for you to know. This is something very important. They say, where does the slope equals minus 1 1/4? We are saying, based on the original function, where x is equals to a, and we find the curve or the slope to be minus 1 over a squared, this slope will be minus 1 1/4, provided that minus 1 over a squared is equals to minus 1 1/4. And then from here we can cross multiply. I'm going to say minus 4 equals minus a squared, divide both sides by negative. 4 equals a squared, and then when you take the square root, you will find plus or minus 2 is equals to a. Right, you can see that this equation is equivalent to this, so that we have a that is equals to 2 and a that is also equals to minus 2. So we are therefore saying the curve has a slope of minus 1 1/4 at 2 points. This is very important, at 2 points. So which points are those? So the first thing we have, a equals minus 2 and a equals 2. So I'm taking this value, substitute on the original equation, and this value, substitute on the original equation, and find out the following. So when a, which is equals to x, and x is equals to a, when the value of x or a is 2, you will find the corresponding y value of 1/2. Secondly, when you substitute minus 2 on the original equation, you will find the corresponding y value of minus 1/2. This is very, very important. So where does the slope equals minus 1/2? It is equals to minus 1/2 when a equals 2 and when a is also equals to minus 2, or when x is equals to 2 and x is equals to minus 2. So this is very, very important for us to understand. Right, and then let's look at the last question, which is number C. They say, what happens to the tangent line to the curve at the point A and 1/a as A changes? So they are saying, what happens to the tangent line to the curve at the point A and 1/a as A changes? Now, we know that the slope, which is the gradient, is equals to minus 1/a squared. And this is always negative. Whether a is positive or negative, it doesn't make any difference. Right, we are therefore saying, if a is not equals to 0, as a approaches 0 from the right. Now, I want us to look at this so that you see what I'm trying to demonstrate. I know that 1/x is a hyperbola, which is on the first and the third quadrant. So this is equals to y equals 1/x. And I have these points that I have found there. Alright, I know that if this is 2, it has a corresponding y value of 1/2. And if this is minus 2, it has a corresponding y value of minus 2. And remember that the gradient here, the slope, which is the gradient, it's minus 1/2. And again, the slope in here is also equals to minus 1/2. Alright, so remember that is what we found. Where does the slope equals minus 1/2? It is equals to minus 1/2 at 2 points, hence I'm drawing that. We saw that at minus 2 and 2. Nothing is new with this. Right, remember what we are saying. We are saying that the slope minus 1/a squared is always negative if a is not equals to 0. This is very, very true. We saw that. And then as a approaches 0 from the right, very, very important. As we approach 0 from the right, remember we are approaching from the left and we are approaching from the right. From the right, moving in that direction. So from the left and from the right. So we are saying as a approaches 0 from the right, the slope approaches negative infinity, and that is true. As we are approaching as a approaches 0 from the right, where are we heading? Negative infinity. And the tangent line becomes increasingly steep. This is very true. We see this situation again as a approaches 0 from the left. There it is. So what happens from here? As a moves away from the origin in either direction, the slope approaches 0. Now let us look into this. As we approach a from the left, if we are approaching from the left, this we are moving, let's say. So as we are moving away from the origin in either direction, if I'm moving from the origin and I am moving away from the origin, can we see what is happening here? The slope is approaching 0 in either direction. As I'm moving away from the origin, I am approaching 0. As I'm moving away from the origin, I am approaching 0. And the tangent line is leveling off. It will end up leveling off. Okay? And it becomes more and more horizontal. And we can see that it becomes more and more horizontal. This is the horizontal line. Okay, so that would be my answer. What happens to the tangent line to the curve at point A and 1 over A as A changes? So I have A and 1 over A. And which one is that? Is this one? A and 1 over A. As I'm moving away from the origin, the tangent line, in fact, the slope is approaching 0 and the tangent line levels off, and the same is happening. But in this one, as I move away from the origin, can you see that? The slope approaches 0 and the tangent line levels off. And that would be my answer for this question.